Welcome to Aerial Services LiDAR Applications You Can Use, the second of 3 webinars in the Aerial Services 2013 Summer Webinar Series. This is your host, Joshua McNary, Director of Corporate Development at Aerial Services. We are pleased you have joined us and hope you walk away having learned more about how you can use your LiDAR for your geospatial applications. But first, a few housekeeping notes. 1. You may ask questions via the questions pane on your screen. We'll collect these questions for responses from the speaker at the end of the presentation. 2. We want your feedback. Contact us via the questions pane or via the post-webinar survey with any ideas, suggestions, or concerns regarding the webinar. 3. The post-webinar survey will appear on your screen after you leave the session. Please use that as an opportunity to share your feedback. 4. Lastly, but not least, note that Aerial Services will have another webinar soon. On July 31st, our President and CEO, Mike Tully, will be discussing ortho and LiDAR accuracy. Also, look for an announcement soon regarding our fall webinar series. Keep an eye on www.aerialservicesinc.com/webinars for more information and to register. I am now pleased to introduce my colleague and friend, Aerial Services LiDAR Specialist, Adam Campbell, who will share his expert knowledge with you today. Adam is a talented up-and-comer in the Aerial Services organization, starting with the company in 2008. He graduated with honors in 2009 from the University of Northern Iowa with a BA in Environmental Geography. He also received a certificate in GIS. He currently leads the LiDAR team to process and classify point data, while also completing final QA/QC for projects. In the past, he assisted with imagery preparation for orthoimagery projects and supported programming initiatives, including geospatial databases and web services. So with that, I'm happy to turn the session over to Adam, who will get on with the show. Adam, the floor is yours.
Thanks, Josh. Good afternoon, everybody. Hope you're all having a good day. In today's webinar, we will be focusing on LiDAR. Since our audience consists of people who range in experience with LiDAR from little to none to well-versed and have been working with it for years. With that in mind, we're going to gear this talk towards those who have a limited LiDAR experience, and then at a later date, we can do another webinar that goes more deep into the various applications of LiDAR, because there are so many. And if any of you want more details on a specific application after this webinar, you can get in touch with Josh, me, or any of our geospatial managers, and we can go over in greater detail just how LiDAR can help you do what you need to do. All right. So first off, for those of you who have the limited amount of experience, we'll go over what exactly LiDAR is. LiDAR is similar to radar and sonar in that it sends an active signal from the sensor, and then it collects the return of that signal to give its three-dimensional point cloud. It is very accurate and precise, and its applications are almost limitless. If you're going to acquire your own LiDAR data, you're going to need a few things before you get started. One is an inertial measurement unit. This is used in the aircraft to collect the information about its roll, pitch, and yaw, and any other slight movements in the aircraft or the vehicle in which the scanner is being used with. And this will allow the people processing it afterwards the ability to rein in the accuracy of the data more precise. Also on board will be a GPS. This will collect the speed and movement of the plane or helicopter or car as it's going, and this will be also used with the data to give us our trajectory, which allows us to give you precise data. As well, there are also multiple types of scanners in which you can use to collect the data. On the upper left-hand corner, we have a terrestrial scanner. This is used in such applications as indoors and in small areas like mining, where you can get a lot of point density, but is limited to that small area. The one in the middle is a airborne scanner. This allows you to take it up in a airplane, helicopter, or UAV, and you can use this to either cover large areas of space, you can access places that are hard to find, or you can just cover a lot more area in a short amount of time. And finally, the scanner on the bottom right-hand side is a mobile scanner. This can be used on a railroad car, on a all-terrain vehicle, or on a car or truck. And this will allow you to get a ground perspective of a corridor along which it drives. So if you're going to choose any of the options other than terrestrial, you're going to need a platform on which to mount your scanner. So on your left-hand side, there's an image of one of our planes. You can also mount it on a helicopter or on the back of a vehicle. All right. In addition to that, you're also going to need a few other ancillary data. For example, if you're working with transmission lines, a good idea is to have a weather station so that you not only know the time at which your data was collected, so you know the usage in those power lines, but you also know what the ambient temperature and the wind was out at that time, just to give you a more clear outlook of what your data is really telling you. Another thing that is useful to have are base stations. You don't necessarily need them for all cases. With longer flights, you can, there are methods in which you can not use base stations, but to have more control over your data, it's a good idea to either set up your own personal base station that allows you to give you a reference point to tie your data to, or there are several public or accessible networks that act as base stations, such as NOAA's CORS, or in Iowa here, the DOT runs a real-time network of base stations that are continuously collecting data and are made available shortly thereafter. Now, with the scanner, there are several types of them. One of them is a scanner that has a oscillating mirror that goes back and forth, and many of them have dual pulse lasers that send out 2 pulses of lasers, and they bounce off the mirror and go down, hit the surface, and will eventually come back. With this, though, you have the mirror slowing down as it approaches each turnaround, and so at the edges of your swath width, you have a high collection of points that are close together, whereas in the middle, they're spaced further apart, and so you're left with you're not able to say exactly what your point density in a specific area is going to be. It's determined on where in your flight line it falls, the subject falls, and if there's a change in elevation or the pitch of your aircraft changes, it will affect that as well. So there's another type that's a rotating mirror, and this continually revolves around, and the laser pulse is shot out continuously, and it then is pulsed out in a regular gridded format, and so it's easier to determine your grids or your point spacing. So if you know that your subjects are scattered throughout the area, you can determine how close and how you need to fly your flight to to guarantee coverage in the density that you want it. Now, after the laser pulse is sent out, it will reflect off of whatever object it hits. So in this example, the laser pulse bounces off a tree. It will return up, and whatever the scanner is able to collect, it does so. But since the laser pulse may actually go further beyond just that tree, part of it may continue on to limbs further down or all the way to the ground. Those will also reflect up and return to the scanner, and it will collect the full waveform of the returning pulse. The returning pulse will look something like this, in which you have the pulses or the wave increase as it hit an object. So you can see as it hit the tree canopy, it returned pulses, but then as it hit branches further down and the ground at the end, it returned a second and third returns of that laser pulse, and the scanner is then able to determine exactly where in there that it hit those objects. So this all keeps happening continuously, and more pulses are sent out at rates of tens of thousands to hundreds of thousands pulses per second. Now, after your data is collected, you have a lot of information at hand already. One of the things is intensity. This is the reflectivity of the object that the laser pulse hit. And so in this case, you have Wartburg's football field in Waverly, Iowa, and it almost looks like a black and white image, but what it really is are the points reflecting off the surface and the intensity of that surface it hit, and it gives you, and so a lot of data about the water in the area, and also roads and other man-made features can be determined just from that intensity data. One of the most useful things that comes right out of it is the elevation. Right away, you'll be able to look at elevation differences between your ground surface and anything above it, such as power lines or vegetation. And then they also have their absolute position, so they are theoretically be able to combine with any other point data in that area. So in this case, we have the outside of a hotel that was collected with a mobile scanner, and then that same hotel as collected by an airborne scanner. Those can be brought together and actually combined so that you have a full 3D look of the area you're looking at. And again, we'll look at another instance of this with a transportation. The bottom road was collected using a mobile scanner, and so you have the road and the underneath the overpass, but on top of it, you're missing the road structure up there. Well, this can be collected with the airborne scanner and combined together into a full analysis of what is contained there. But one thing you're missing is classification. That's not all LiDAR is good for by any means, but it's one of the big things that people like to see from their data. So now that you have your raw collected data, what do you do with it? Well, one of the main things you want to do is make sure that it's accurate, because that's one of the main appeals of LiDAR data, is that it gives you the accuracy that nothing else really can. So to do this, one way is to set up control points with reflective targets, such as here. And then when looking at your LiDAR data, you have the surveyed point that was collected, and you can look at it vertically, make sure that it matches with your data, as well as horizontally. You can determine its accuracy in the X and Y dimensions by looking at the reflectivity or the intensity of your data and finding that target and verifying that that control point that you measured falls right where it should in your data as well. You can then run this over all your control points or checkpoints and verify that the data that was collected is the data that you want. Another big or important use of LiDAR data is being able to classify it to determine different features from each other. One of the main things is being able to find the bare earth surface for building DEMS for various applications. So as you can see here, all this area has been classified into its specific category. You have your vegetation, your buildings, your roads, parking lots, fences. Pretty much if you have a point that lands on an object, you'll be able to classify it. And so no matter how small an area or specific item you want to look at, if you have the point density to look at it, you can then classify it. Here we have a larger area that contains roads, buildings, a river, railroads, vegetation, and large areas of open ground. All this can then be, you can turn all these layers on or off and be able to look at them individually depending on what specific application you're doing. So if you're looking at vegetation, doing a vegetation analysis, you can look at just that feature and determine what the specific biomass of an area is. And there's just another image to show you all the detail that you can get with a LiDAR collection. You can just get your different types of power lines. You can even, within a power pole, you can find the different components that make up that power pole. You can get your roads, bridges, cars, fence lines, pretty much anything that there is, you can collect it. And here we will look at a short little video to see exactly a step-by-step process of how these are taken from a raw point cloud where everything's the same, and it's put in, each type of feature is put into its own specific classification. So here we start with a point cloud in which all points are really same as the other except for their XY position. But then you can run different macros and manual classification techniques to get your roads and your parking lots, buildings, signs, trees, fences, all that can be differentiated from each other. And then once the classification is done, you can even go a step further and vectorize different features in your area. In this case, we vectorized the power poles and power lines so that they can be used in the planimetric mapping. We'll then go back to our presentation. So as I mentioned, one of the main advantages of LiDAR is then it can be used to develop other types of products. So if you're looking to have vectors of our planimetric mapping of all the features in your area, not only will you have a point cloud of your data, but you can also have the planimetric mapping for roads, bridges, buildings, waterways, pretty much anything that you can collect in using stereo mapping, you can do as well with LiDAR. So as we look here, with the vectors draped over an intensity image on the right, you can see how with their absolute position, you can get your planimetric mapping exactly where those features lie. When these are overlaid over a orthophoto, as on the left, you can see any feature that is above ground has a disadvantage of perspective, like the water tower that has lean to it. So if you're taking the image from straight above, it's not going to be in absolute position. So you need stereo photos to be able to map that, whereas with LiDAR, the absolute accuracy or absolute position of the data is already there. Another advantage of LiDAR is just all the different things that can be derived from it. As you can see, all these are also in 3-dimension. All these you can interact with all these different products independently of each other or with each other, so that if you see something in one type of product, you can look at it in another and see exactly how they correlate with each other. So here we have our classified point cloud, but then this can be used to give you contours, a DEM, a color shaded DEM surface, a hillshade, your planimetric mapping, and then when combined with your ortho, you can also drape your ortho photo over your DEM surfaces to give a 3-dimensional ortho photo. So one of the cool things about LiDAR is being able to immerse yourself into this 3D environment instead of only looking at 2-dimensional imagery. But one of the main things you want to be able to do with it is then interact with your data and not just have it handed to you and looking at it from a top-down perspective. So one of the things that LiDAR can do for you is generate reports in which you can, for transmission line, you can see exactly how close any of your the trees along your power lines are to the lines, and so you can know exactly where to send out crews to trim those back to avoid any potential fines or costly outages. Another cool thing that is being developed right now is there's GeoPDS, and these allow you to, if you have any like Adobe Acrobat, or it's like viewing any other type of PDF, except it contains a mapping of your area. But what is also being developed right now is 3D GeoPDS, in which It's delivered in the same format as a PDF and can be opened by Adobe Acrobat as would a normal PDF, but you can actually go in and rotate and zoom in and perform analysis on your data right from a PDF page. And then we'll view another video here of just what it's like to go through, interact with your data in a fly-through mode. In this case, we collected power line data for the city, and then we provided a fly-through in which you can actually go right down the power line and see which areas are close to the power line, and instead of just being told where there might be an issue, you can actually go and see for yourself in your actual data where a problem may need to be addressed. Finally, so after all this, we have all this data, what applications can really be used with it? And to some degree, all. In some applications, it might be a way that is combined with other means to provide a accurate or a way to see your project more fully. In other ways, LiDAR can pretty much give you everything you need on its own. In this case, transmission lines, which we've seen some examples. You can fly an aircraft down your transmission lines and get high density collection of just your specific corridor and not all of a bunch of area around it that you don't necessarily need. So in this case, we flew a transmission line corridor with a buffer on either side, but this allows us to get our most amount of points in the corridor while still covering a large area using an aircraft. Again, this shows you that with this data, you can then see how close potential danger objects are to your transmission lines, and you can send your crews out immediately to go remediate these areas. And it's just an image to show you that just what you can see with the LiDAR data. You can see everything from the pole to the guy wires, the transmission lines, and the attachment points to the jumper. All of these small features that are on the power poles can be picked up using LiDAR. LiDAR can also be used with resource management. It can be used to model the terrain surfaces around it. It's been used on coastline or coasts to help mitigate erosion. It's been used by people to determine the amount of sunlight that is collected by a building top and the area of that building's roof structure, so that you can determine whether it's a suitable place to put solar panels. And in this case, with these images, the intensity was of great use in determining just where wetlands are in Minnesota without having to send field crews out to explore these areas and find them on their own. Agriculture is a popular use of LiDAR. The high accuracy DEMS that can be generated using LiDAR data, in addition to other information such as the crop yield of the farm, can tell you just how and where to apply costly fertilizers and save the farmer a lot of money on saving the fertilizer for the areas that needs it the most. It can also help reduce runoff that would go into the streams and environment, so that we can help save that as well. Transportation has been making use of LiDAR quite a bit. With mobile mapping, it allows you to look at exactly your road structure. So, and as we showed before, that combined with airborne data, you can get a total view of every structure on the road, and including the overpasses above and below. With a mobile unit, you can also attach a camera behind it as well that collects data as you're moving along. And so if you're trying to inventory everything that you have along the roadways, you can see it in your LiDAR data, and then you can cross-check it with the imagery that you collected from a camera and verify everything that you have there on the road without sending a crew to go out and stop every so often when they find something and collect the data. It's all contained right there as you're driving by it. With oil and gas, LiDAR allows you to a very accurate depth and terrain surface, and this can be you get your surface model, and it can be combined with other types of sensing that will detect the subsurface features, and also any leaks that are down there using magnetometers. And this can all be combined to help you map just what needs, or anything that needs to be worked on in the area, and give you accurate mapping of your center lines and depth coverage and high consequence areas. And then with also another area, railroads are starting to make use of this now, as opposed to sending groups out there, or survey crews out there that collect points every so often and using aerial photos. You can instead do LiDAR, and you get just as accurate, if not more accurate data. You can get a higher density of data, and this can also be used then to give you your highly accurate DEMS, drainage mapping. You can do cross sections off of this, and you can also map anywhere and nearly anything, whether it be natural, man-made, or hard to access locations. And here we have, there's even more of the applications that you can really use with LiDAR. You can do landslide susceptibility, glaciology, change detection. The military has made use of it, as they were the first ones to develop it. They can be used with vehicles to do object avoidance, and you can also, it's also been used to map the surface of features beyond the Earth, such as the Moon, and we'll be able to map Mars as is being more fully developed, or more fully explored. So, lastly, what's the future of LiDAR? Since it's been changing so quickly in the past few years, it will also continue to develop in the years to come. One of the fastest growing areas and areas that is in the news quite a lot are UAVs. LiDAR will be able to utilize these UAVs to go into areas that aren't as accessible to even larger aircrafts or manned aircrafts. These can go into mountain ranges and collect LiDAR data that is just not feasible to collect by any other means. Laser scanners are getting small enough now that they will be able to attach to these UAV vehicles. LiDAR is also being utilized by self-navigating vehicles such as the Google car. LiDAR is used to, in this instance, to avoid obstacles, and it's almost while it's collecting data, it makes it almost impossible for it to crash into another object, unless if it's crashed or impacted by another vehicle. So I believe there's been a few crashes related with the Google car, and all three of them that have been that have happened are due to another car running into it. So LiDAR will continue to be developed for mobile uses such as this, and in the years to come, it'll be interesting to see just how far it gets developed into our way of life. And then one of the biggest things for LiDAR is just helping GIS get more ingrained and useful in everyday ways of life. Like I mentioned earlier, the 3D GeoPDFs are a way for the people out in the field to be able to access accurate surface realistic models of the area they're interested in. And so the data is not just sitting in an office where somebody is using it and discerning it there. It can be out in the field with the people or with the field crews, and they can be looking at it and making determinations as they need as well. And another way in which it's being developed is making Google applications such as Google Maps and Street View more realistic for all the people that use it. Most people are comfortable using those currently, but in the future we'll see LiDAR being useful in helping people navigate and explore the world around them more interactively without them even having to go to their computers. They'll be able to hold it right there in their hands. And just a few of the other areas in which LiDAR is being used or being researched in using. Atmospheric composition is one way and that they're making use of it, as well as combine it with security footage for police investigations, future space exploration, increased the 3D elevation program and National Digital Elevation Program is one of the largest areas in which LiDAR is about to find its footing. So with that, I'll wrap up my section of the webinar. If you have any questions, feel free to type them into the question box on the side, and Josh will collect those, and we will try and get them answered for you the best we can. Thank you.
Thanks, Adam. That was a great talk. Appreciate your time today to share some of your knowledge with the audience today. So now, as Adam said, we'll get on to some questions. A few comments on this before we get started. We don't want to get overly project-specific during the Q&A, so if you have any project-specific questions, we'll defer those and get back to you at a later time. You can also feel free to call us at any time to discuss any remote sensing issues, whether it be orthoimagery or LiDAR, or any of the services that we provide, or even just general questions. We're always here to help you. So with that, we'll go ahead and hit some questions here, Adam, if you're up for that.
Yep.
Okay. So we had a number of folks ask during the presentation about what software packages we use. So I know you use a number of those each day to do your work. Can you tell us a little bit about the core software packages that we use and how you use those applications?
Yeah. Well, after the data is collected from our scanner, we use a Regal scanner. So we then use its proprietary software RI process to calibrate the data and verify its accuracy. In there, we'll verify that it's matched up with each other, and we'll also bring in any ground control data that was collected for the project as well, and just verify that everything is exactly where it should be, as was seen in a couple of those slides. We just verify that any of those are matched vertically and horizontally to known points of interest. From there, we export it out into the LAS format, and there we use the TerraSolid software to help in the post-processing of the data, and it is in there that we will do a majority of the classification and vectorization of the features. In addition to that, as needed, use VR and other CAD software like AutoCAD, and just to assist in any planimetric mapping needs.
Great. That's a good summary. I think that covered most of your questions. A number of you asked that question, so hopefully you got that answer. If you have additional thoughts on that, feel free to holler at us here. I had a question came up about 3D city modeling. I think you showed some examples that could apply to modeling cities. But can you speak to that, and have we done any applications like that, or what's the applicability to doing any kind of 3D modeling of let's say, an entire city?
We haven't necessarily done a lot of this far. We have done a little bit with it for certain projects, in the sense to give a realistic fly-through mode to the client's data, so that they're able to interact with it with the building models.
You've done some things on a few of the projects where you've done the photo draping on top of the existing LiDAR data to give that effect of a 3D model.
Yes, it allows you to interact with the data in a more realistic, hands-on feel. And in ArcMap and other programs, you can go even larger and do entire citywide, and this can assist in city planning or public marketing for the city and various other applications that are being derived all the time by these cities.
Great. I have a question here about LiDAR and water. You mentioned that during the presentation. I think this gentleman is interested in bathymetric type surveys, and can you tell us about LiDAR's applicability to those type of surveys?
Okay. Well, without going too specifically into this, LiDAR can be used with bathymetry, with many scanners, like ours is one where it's made specifically for land use, and we do get some cover or some return from the water, but mostly from just a vertical position, and that's just going to be the water surface. There are other LiDAR scanners that send laser pulses out at different wavelengths, and I believe these veer more to the green and blue wavelengths that actually penetrate beneath the surface more so that you can actually get a subwater surface of an area you're looking at. And so for this type of application, you'd want to make sure that you're using a scanner that is made to do this.
Our scanners have a red light as far as the light that's being refracted, generally, correct?
Correct. Yes, ours is longer than the wavelength's longer than that.
And we do have some partners and friends that know how to do that kind of work, and we obviously have the knowledge of the technology there. So if you have any additional questions, we could put you in touch with those folks. Just give us a holler. I have a question here regarding the presentation itself. I just want to note that we will be sending out information to all of you in the coming days with regards to this webinar, both slides of the presentation as well as a video version of this. So please look to that in your email inbox in the coming days, no later than early next week. I have a question with regards to LiDAR and the field of architecture. I've seen some really interesting applications, maybe inside of some beautiful churches or on the face of a building that perhaps is about to be a historic building. They want to preserve the historic nature of it, so they scan it before they go and they do any kind of remodeling. Have you heard any other applications in architecture or seen anything that comes to mind?
You covered a lot of it pretty well there. Is preserving the surface for how it looks currently is one area, and using a terrestrial scanner, you can take LiDAR indoor and get everything inside, as well as then taking that scanner outdoors and collecting the entire outside structure of it. As far as architecture, it can basically anything that you can see and would want to model for being able to view in a 3D environment. It's probably the best way of giving you a realistic way of doing that, as opposed to just animating it by hand beforehand.
You really get a true as-built when you scan it this way versus any other way that we could really think of.
Correct. And this kind of a tangent as far as its use with architecture. It's been used to help identify buildings and features in areas where they didn't even realize that those were man-made features to begin with. So in the field of archaeology, even just this last weekend, there was a lost city that was found in Cambodia that was found using LiDAR, and it helped determine where exactly these man-made features were. When looking at them with your bare eye, you couldn't see it just from the scratch.
Interesting. I did not hear that. It's interesting. So you were talking a little bit earlier about the amount of points that could be laid down on the ground. You talked about flying low and slow, perhaps for a particular application, to be able to get that from an aircraft or other applications. Can you kind of give us an idea of what kind of amount of data points can be hitting the ground in a given area?
Well, yes, that all depends on your specific application. If, for instance, if you're doing something that you want highly accurate and a lot of data or a lot of coverage on, we can easily range upwards of 40 and 50 points per square meter with our sensor. But if you're looking to do something over a larger area where you don't necessarily need as many points per square meter, but looking for a large area of coverage, if you drop that down to a still large size of 10 to 15 points per square meter, you can cover a lot larger area in a smaller amount of time and still give you that highly accurate DEM or surface model or whatever you're looking to achieve from that.
So our sensor sends out something like 300,000 points per second or something like that. And then, of course, you got to do the math to figure out how many actually hitting any given square meter. Some of the other applications out there, whether it be terrestrial or mobile, can vary in range here. I have a note that says that some of our mobile partners that we work with that have the mobile sensors can get up to 800 points per square meter, something like that. It's pretty amazing what can be done, isn't it?
Yeah, and with these, they have the advantage of giving you a lot more points per square meter. So that is one of the big reasons why the terrestrial scanner is great for like indoor or small areas, is that it gives you extreme detail in these areas, but they can be limited in the amount of area that they can cover. To be able to get a mobile scanner over an area that there are no roads or anything, it's more trouble. So it all depends on your application, but yeah, you start with more density with the terrestrial scanners and work your way down a ways to your airborne scanner. So.
Yeah, I mean, even for us, as you showed it earlier in the presentation, we both do the fixed wing aircraft, and that gives us a certain amount of coverage and a wider availability of how much area we can cover in a given time. But then we often fly our sensor in a helicopter because we're able to fly slower and lower in those situations and get the higher coverage. So even among our platform, there's a great variance in the amount of data we can collect.
Yep.
So what is the smallest feature that you have worked with, like that you've actually been able to sense in your experience here with Aerial Services and the LiDAR sensors?
I'd say road signs is one of you can certainly hit objects that are smaller than that, but for our use, we haven't wanted or needed to classify or differentiate any small like manhole covers or small features like that, even though it's possible. But one of the features we usually classify is signs, whether they be road signs along the road or any other of those. They're pretty small and they're skinny, and so it was surprising to me the first time looking at it, just how many points we had on the signs, and are able to take that out or differentiate that.
Well, and I mean, right now on our screen, there's a picture of the power line, and you used many examples of that. I mean, that's a small feature in and of itself, although it's long. It's an amazingly small area to be capturing.
Yeah, and even the arms that go out to the lines, as well as the lines themselves, are very far themselves.
So I have another question come in here now, Adam, and as we're wrapping up, we're only a few more minutes left, so if you have any last questions, get them in now. There's a question here with regards to vertical and horizontal accuracy of this data, and I know that's going to vary because we just talked about all these different potential ways you can scan, and that plays greatly into the accuracy, in addition to what kind of control you may have on the ground, and there's just many different scenarios given on a given project. But can you give a sense for the type of accuracy that are possible with LiDAR? Yeah.
Well, like you said, it is very dependent on how you approach and set up your project. But when horizontal accuracy is something that's important, we can certainly get horizontal accuracies as low as 4 to 5 centimeters of an RMSE value. And as we saw in one of the image of control sides, that our control was falling directly on top of where the target said that control point should be. And so, yeah, when that's a priority, horizontal accuracy can be confined down to just a few centimeters.
How about in the vertical?
Vertical, with our scanner, we often try to attain vertical accuracies no greater than 5 or 6 centimeters, and most of the time we're downward between 2 and 3 centimeters of accuracy.
Yeah, pretty amazing.
Yeah.
Pretty amazing. It looks like we have one final question that came in. Appreciate that. So this question has a relationship to cost, and as I know, we're not going to get into specific project type details here today. But what's kind of the general applicability or the feasibility of a smallest area that we would go fly? Or what maybe tell us what is kind of some of the smaller areas that you've flown? Give us an impression of that, where this becomes a cost-effective concept.
Well, for a project that we did for Johnson County, here in Iowa, it was a relatively small area, but it was being able to provide them with high accuracy data that just is unable to be matched by other ones. Once you're out there in the field working on it, having that accuracy pays off in the end. So
was that like a couple square miles, or
that was actually only, I believe, 3 or 4 miles in length and just a few hundred feet wide. So
there's a corridor type.
Yeah. So it was probably less than maybe 1 total square mile of work, and it paid off for them.
Interesting. Great. Well, we appreciate everyone's joining us today. We're about out of time for today's allotted presentation time, but we want to thank you for coming. And we wanted to remind you that as you leave today, you should see a webinar survey appear, and we'd appreciate your feedback on that. I want to thank Adam and my colleague Amy here, who's been on Mission Control, for their work today to help present this webinar to you. And we thank you again and ask you to please join us at another Aerial Services webinar in the near future. Have a great day, and we'll talk to you soon. Bye now.